Okay. Okay. Hello, everyone. Welcome to the first or 0th lesson for CS 19899, Introduction to Full Stack Web Development. Yay! This is a 3-unit decal offered by Web Development at Berkeley through the Department of Electrical Engineering and Computer Sciences at the University of California, Berkeley. I, myself, and Kim, you want to say hi?
Hello, everyone.
Kim and I
we'll
are
do the official intros in a bit.
Yeah. Kim and I are your facilitators this semester. So we help run the course logistics, the ed, the enrollment, and everything. But throughout the semester, you'll hear from all of our TAs. We're not the only lecturers, and so we hope that you'll get a really wide variety of experience with a lot of our staff and a lot of different people with a lot of different interests. So let's jump. Today is mostly introduction, kind of an overview of just a short overview of the course. And then I'm also going to go over Git. And I'm just going to give you a really quick intro to HTML, CSS, and we're going to build something together. So let's get started. Oh, if I can click the slides. Okay, so like I said, my name is Dhruv. Kim. That's Kim.
I'm a junior studying data science and CS. Yeah, welcome to the Full Stack Decal. It will be a lot of fun. It'll be a lot of learning, but we are all here for you, Drew, I, and all the course staff. So feel free to reach out to us whenever.
Yeah, and my name is Dhruv. I'm a 3rd year studying electrical EECS and BioE. This is my 3rd semester on staff, and and my 5th semester in web dev at Berkeley. So in case you didn't come to the info session, Kim and I both started off as students in this club. And now 2.5 years later, we're really proud to be offering this decal and helping pass on a lot of the knowledge that we've got and that web dev has enabled us to work with. And so we hope that you gain a similar appreciation for it. Potentially, the slides are not updated for this semester. So if you're a TA, why don't you just go ahead and introduce yourself?
Hi, I'm one of the TAs. My name is Abby. I'm also a 3rd year EECS major, and this is my 1st semester on course staff. And I was a student last semester.
Hey guys, I'm Karthik. I'm a sophomore studying EECS. I took the decal last semester and I'm teaching this amazing decal. Really excited for you guys.
Hi, I'm Nithya. I'm a senior studying CS. This is my 2nd semester teaching this decal, so I'm excited for everyone to be here.
Hi, I'm Isabel. I'm a 3rd year studying data science, and I'm the design TA.
Okay, I don't see anyone else on, so I think that's great. I'll just say about our TAs, we come from all kinds of backgrounds. We come from all kinds of majors and academic interests, all different years, all different types of, internships and industry experience. So if you ever have any questions about, industry or software engineering, or what you can do with CS principles, what you can do with web dev, asking each of our staff is bound to give you a different answer each time. So really feel like you guys are welcome to engage with us. We're students, you're students. Think of us as peers who are happy to help you out. This decal is as much about the community that we're trying to build as it is about the skills we're trying to teach you. So feel free to reach out at any time or in the chat or through DM or email or ed, and we'll be happy to help you out. Okay. So what is full stack development? So full stack development consists of 3 parts, this decal consists of 3 parts. So this decal starts with the basic stack. The basic stack is what we call the fundamental building blocks of web development. And those are HTML, CSS, and JavaScript. And we're going to go into a lot more detail about those in a second. But what you basically need to know is that that's where the internet started. So building out web pages in HTML, decorating them with CSS, and functionalizing them with JavaScript, those were the very first iterations of what a web page is. And a lot of the modern technologies that we use are, to a large extent, built on those 3 technologies. To this day, those 3 still power a vast majority of what we do on the internet, or at least what you see on the internet. And so understanding those is kind of giving you the first building blocks you need to succeed. Next up, we have the front end part. So the front end talks about everything that you interact with when you are on a website. So, the buttons you click, the pages you look at, the portals you enter information into, the boxes that you query, everything that you touch is front end. And so that includes what we call React, which is an advanced JavaScript framework, as well as principles of design. And so teaching you not only what it's like to engineer a front end, but also what it's like to design an attractive front end and make your front end appealing to the consumer. Finally, we have the backend track. The backend is everything you don't see. So when you click a button, you send a query off into the unknown. The backend is what takes that and handles it and processes it and returns to you information about what it is you're actually wanting to know, whether it's about yourself, whether it's about something in the world. The backend stores and processes all the data that we send and sends you back the appropriate response. So that's kind of an overview of the class. We're going to start with the building blocks. We're going to teach you how to build a front end, teach you how to build a back end, and then we're going to connect all of these principles up into one large web application. And so you should walk out of here knowing how to create a web application from the bottom up. We don't expect you to do that alone. It's a very heavy task. Think about how big a company like Google or Meta is. Those are all just web development companies. And so it's a big ask, but we hope that we can give you the skills to at least understand what's going on. Okay. This is just kind of an overview of what I already said, but we start with the basic stack, HTML, CSS, JavaScript. These are some front-end tools. These are some back-end tools. We're going to go into a lot more of this later. This is just kind of for your reference. Okay, I'm not going to go over this again. But just know that in addition to HTML, CSS, JavaScript, we also teach you how to build some of the basic tools or how to use some of the basic tools in software engineering. So you'll learn a lot about how the internet works, not just the websites we build on it. You'll learn a lot about GitHub, as in how to use Git, how to use version control. What is version control? You don't need to know what that is. And just a few other miscellaneous things that help you get into a software development workflow. Okay, yeah, same thing. Like I said, a lot of companies use these things. This is industry standard stuff. All of us or most of us have worked in industry or on some kinds of projects. And so we try to teach you industry standard tooling, and same here. Okay, so I'm going to actually switch over to the syllabus here so that you guys have a single source of truth. And we're just going to walk through it very, very quickly. I know nobody wants to sit through the syllabus, but I'm just going to go over it quickly. So this is Introduction to Full Stack Development. It's a 3-unit taught by or sponsored by Josh Hug, but taught by myself and Kim along with our TAs. There are 2 lectures every week. They're remote and recorded. Attendance is not required, but students are expected to watch lectures and keep up with the material. So somewhere after Wednesday's lecture, we'll be posting a content quiz. And that content quiz will basically be a very preliminary check to make sure that you're up on the content, that you're understanding the course as it goes along. This course is very heavy. It is very, very easy to fall behind. Do not fall behind. It will be difficult to catch up. Of course, we're here to help you catch up if you do fall behind, but to make it easy on yourself, we just recommend either coming to lecture or watching it as soon as it's posted to try to get you as far as possible. Okay, I want to talk about this briefly. So this is a no prior CS class. This is an NPE class. So we basically strive to teach you all of the fundamentals that you need to know to get through this. I will say, if you have not worked in software before, you may find it a little bit difficult to wrap your head around some of the workflows that we'll be using, especially with Git and things. If you're struggling and if you have no prior experience, please don't feel discouraged. A lot of us came into this school with no prior experience. I came in with no prior experience. And in order to help with that, we offer a lot of TA office hours. We're going to offer homework party. We're going to offer a lot of different things and extra support for you so that you can get kind of individualized attention if you need that to help you kind of make sure that you're at the knowledge level you need to succeed in this class. So yeah, there's 2 lectures a week, 1.5 hours each. Each lecture corresponds to a homework, which can be pretty heavy course load. So just try to manage your time well. We're pretty flexible with extensions. So if you're falling behind, if it's a midterm week, if there's something you need from us, just feel free to make an private ed post, and we'll see what we can do to help accommodate you. We don't want this to be like a knuckle or like a teeth grinding experience of you grinding through 1,000 problem sets. And it's not, the problem sets are not meant to trick you. They're just meant to give you practice with the concepts. So if you ever need help, if you ever need an extension, just let us know and we'll be happy to see what we can do. Okay, learning goals, you can definitely go through those on your own, but the idea is that not only should you learn web development, but also software engineering principles. So how to work in a software engineering development environment. So yeah, the main 2 forms of support are office hours and ed. Ed is of course 24/7. Feel free to post whenever. A TA will get back to you as soon as possible. I would say as much as possible, try to make public posts. It helps other students, and we're not particularly stingy with answers. Obviously, we can't give you the answer, but we try to get you as close as possible. And so it would be easier for us if we could just do that all at once. The other thing is office hours. So office hours are going to be offered pretty much every single day. For a reference of the actual schedule, we have the course calendar up on the website. So if you just navigate to fullstackdecal.com, here's a list of all the office hours that are available to you. These office hours will be updated with either physical locations, Zoom links, or both. You're welcome to attend in person if it's offered in person. You're welcome to attend online if it's offered online. If you need an online accommodation or an in-person request, feel free to, again, make a private ed post, and we'll see if the TA can accommodate you. We try to be as flexible as possible in these situations. And so just talk to us. We're really happy to help you out. Every Friday, there's a homework party. So that's basically a time where there'll be a few TAs around in the Physics 4 classroom. And you can just come by and work on your homework. We're happy to provide you support. This time is our scheduled in-person lecture time. So if you would like to come here, you may. We're also going to use this time to host socials. So like I said, this is not like a traditional class. The goal is to be able to build a community. So we do have socials that we'll be hosting for you to get to know your cohort. And especially as it gets to the final project, as you're maybe prepping groups, as you're maybe thinking about who you'd want to work with or what people you think were interesting, really try to come to the socials. It's a great way to learn from a community of people with really honestly diverse perspectives. As we read the applications, we really wanted to make sure that our community would meld together well and that there'd be a lot of different pockets of ideas that we think would go together well. And so coming to the socials is a great way to get exposed to the kind of like diversity of perspectives that we've tried to bring into the decal. And on that note, there is actually a social this Friday. So this Friday at, is it 3 or 3:30, Kim?
We're doing 2 to 3:30.
2. So from 2 to 3:30, there will be a social this Friday. So it's not mandatory. You absolutely do not have to come. But if you can make it, it would be a great opportunity to meet your fellow students. We're trying to hit the balance between class and club culture. It's a great way to meet new people, great way to make friends in this class, great way to create support systems for this class. So if you can make it, that would be excellent. And more details will come out about that on Ed later. But just keep that in mind, maybe keep your schedule open. You don't have to come the whole time. But I personally think it's an excellent opportunity to mingle with your fellow students. Okay, maybe let's pause for questions. Okay, I'm going to pause for questions. I can't really see, or I guess I can. So feel free to raise your hand if you have a question. Yes. Ahad, am I saying that right?
Yeah, that's fine. Hi, Ahad. I'm a freshman, right? And I don't have too much prior experience. I only took data 8. I'm taking data 8 concurrently. What do you think I should do to, kind of soften the cushion of like the speed, like any YouTube videos to watch or like things to do specifically?
Yeah, I would say more or less we tried to keep everything contained to this course. And by that, I mean that between the readings and the homeworks, the goal is to be able to guide you through everything you need to know. So if anything, I would say just try to be as like involved as possible, like try to actively learn as we go along and get a lot of practice with it. Another great way to learn stuff is to start a personal project on the side. So as you're learning things, maybe you want to start a personal project, and as you learn more and more, you might start like including those things into your personal project and get practice debugging. At the bottom of most of the readings and homeworks, there's additional resource guides. So they're basically links to other resources that we think are going to be helpful for you to learn or maybe look at. So if you struggle on a homework, maybe it'd be a good idea to consult those additional resources and see if they maybe would help you out. Those are the main things that I can think of. And of course, office hours and ed are like the core way to get direct help.
Awesome. Thank you.
Okay, anyone else?
Drew, there's a couple of questions in the chat. If you want to take a look
let
at
me
that.
see. So Gradescope, I was about to send out an email about this. We're waiting for the drop deadline to pass so that we can get a final roster from our enrollment manager. And once we have that final roster, we will add everybody at once. So you don't need to worry about Gradescope. I know a few of you have already finished homework 1. If you haven't, do not worry. That was not expected of you. But yeah, just hold off on Gradescope until Wednesday, at which point you'll be added to the Gradescope and you should be able to submit right away. Okay, what is the relationship with this course and WDV? This course is sponsored by WDV. So all of the TAs and myself and Kim are members of WDV. And so we use their support infrastructure. to help run this course. And this course is also a pipeline for students to go from this decal into the club if they would like. Beyond that, students don't really need to interface with WDB, although WDB members will probably be at all the socials. So if you want to ask questions, if you want to learn more about the club, learn more about software, CS at Berkeley, feel free. You know, the club is a part of this decal to the max extent that it can be. Okay, our socials 2 to 3:30 every week. The calendar says it's 2 to 5. So socials are just us taking out time from homework party to host a social. That 2 to 5 block is ours to use because we have a classroom. None of that time is ever mandatory. So we may host a social, that's not mandatory. We have the whole block, so we may host a social and then homework party. We may just host homework party. We may just host office hours. Basically, that's just free time for us to offer you support. But that's never going to be mandatory. Our office hours all online. That is up to the TA, and that will be reflected in the calendar. So if there's a physical location, then it's probably an in-person. If there's a Zoom link, then it's online. And if there's both, then it's hybrid. Okay, how can I become a member of the club? So in this decal, we teach you a lot of the essential web development skills that you need to know in order to be a streamlined developer. Once you finish this course, you are more than welcome to apply to the club. The club takes on people with some prior experience and ramps them all the way up to industry. So in this class, we teach you the essentials, and then we expect that you'll be prepared for the rigor and skill that WDB is looking for in its actual developers. Okay, that was kind of quick. Does anyone have any other questions? So can I go to the socials after 3:30? If it's still going, the TAs will be around till 5. And you know, the time of the socials may change from week to week. So some weeks we may have 2 to 3:30, some weeks we may have 3:30 to 5. Again, that entire time is kind of amorphous time for the staff to decide, well, how we want to use it. So if you can't make this one, no stress. We will have another one at a different time, probably. I think I saw a question about a Discord. Yeah, you are more than welcome to make a Discord. I can see if any of the staff are interested in making it for you guys. But if somebody makes one, then we're happy to boost it on Ed. We just maybe don't have the bandwidth to administer that ourselves. But if somebody wants to and wants to get people in it, then we can do our best to encourage people to join that and join the community. Okay. Are there any other questions? Okay. Please let me know if I'm talking too fast or if a question is unclear. In general, I try to make these as painless as possible. So let me know if something is missing. Okay, I'm just gonna speed run through the rest of this. Attendance, I think there was a lot of confusion about this. Attendance is not mandatory synchronously. You do not have to be at this lecture to get credit. And we will not be taking attendance here. But we do expect that everybody watches the lecture at some point. And to enforce that, we are going to have grade scope quizzes. The quizzes are not like some timed stressful thing. They're more just like multiple choice, like answer if you know it type things to make sure that you have watched the lecture and are understanding the content. So the attendance category will actually be a series of grade scope quizzes that test that you've watched the lectures for that week. are there any questions about that? Feel free to drop them in the chat. I'm going to move ahead, but I'll always go back and answer if you have questions. Yeah, this decal is a PNP. We set the pass to be 70%. This is a points-based class. So if you ever want to know your grade, you can just add up the points in GradeScope. We specifically calibrated the GradeScope assignments so that you can always check your grade. And this is the point breakdown. So there will be 10 homeworks of 30 points each, a project, and then an attendance score. I think that's 10 quizzes of 10 points each, and then a final project of 200 points. These are definitely subject to change. We're still kind of nailing down like what we want to do with each of these projects if we're going to host them. So I guess technically stay tuned for that. But whatever you see on GradeScope, that is your grade at any given time. So it should be easy to check if you're falling behind. If you are, let us know in advance, like as early as possible, and we'll be happy to help you get back to where you need to be. Okay, there's just some more policies here, which I'm not going to go over, but you're always welcome to reference them. Okay, I think that covers everything of interest. So that's all the logistics. I'm going to move into the like content, but let's take a 5-minute break. There is a question, are there 3 projects? It's still in flux a little bit. There's definitely 2 projects, and the third is kind of, we're not sure about it. So that one's a little up in the air. Okay, so let's, I see a question about our attendance quizzes based on completion. The answer to that is no, they are content quizzes. Can we use Stack Overflow? Yes, you may. If you do, please cite. Always cite Stack Overflow, not only in this class, but in every CS class. You will live to regret it if you don't. It was mentioned that we need to dedicate 6 to 10 hours of this decal. Does that include lecture? Again, the workload varies a lot depending on your experience. So I would say the homeworks take maybe 2 hours each, maybe 3 if it's particularly tricky. So I guess 6 hours goes to just the homeworks probably, slash project, homework slash project. And then the other thing is lecture. So that takes 3 hours. So yeah, somewhere between 6 and 10 hours, depending on your availability, but that includes lecture. Okay, let's take a 5-minute break. Let's reconvene at 7:15. Okay, welcome back, y'all. So that marks the end of boring time, and still begins fun time, which is the start of content in this decal. So today will be mostly about learning how to use your computer for software development. So let's start by talking about this course specifically. So this course is focused around what's called a like Linux environment. So basically that means that if you have a Windows computer, not everything will be the same. So if you have a Windows computer, you will need to install some extra tools in order to get your workflow to work like it's structured in this course. That is definitely something that we can help you with, but would take too long to explain here. So if you have a Windows computer, feel free to come to office hours and we'll be happy to help you set up. With that being said, let's go ahead and look at how this works. Okay, so first thing to learn is how do we use the terminal. So the terminal is essentially an interface between you and the core files of your laptop. Basically, it's a way for me to navigate through the files on my laptop and execute commands on my machine. So for example, let's say that let's say right now I'm in my home directory, right? Let's compare it to Finder, okay? So let's go to documents, right? Okay, what did I do there? Well, I'm in my home directory, okay? A directory is a folder. And so I'm in my home folder, right? And then I go to documents, right? I change the directory to documents, okay? In documents, let's look. So I have all of these random folders, right? Now let's see what's inside, right? Do you see how inside my documents folder, my terminal shows me that I have all of these folders, and my Finder shows me the same thing, right? And so the terminal is basically just our way of interfacing with the file structure on our computer. So when I say directory, I actually mean file. So inside the documents directory, I have all of these other directories, but they're actually just folders. So let's see if we can go in. So when I choose change directory, I'm basically saying go into that folder. So I'm going to change my directory to Berkeley. Then I'm going to do ls. What is ls? ls is list. It lists all of the subdirectories inside the current directory. So I'm inside the Berkeley directory, which was inside the documents directory, which was inside the home directory. And inside the Berkeley directory, I see all of these directories, right? So now let's change directory again to WDB. Let's again list all of the directories. Here are all of the directories, right? Let's change directory to the decal. Okay, let's list the directories. Yeah, truth. Okay, so now I'm inside my directory, right? Let's look at how to get back. If I want to get out of a directory, I use what's called a symbolic link. A symbolic link is basically a way for me to move relative to where I am. So the most common symbolic links are one dot, which represents the current directory, right? I didn't move, right? I'm changing directories to the current directory, right? So cd dot does nothing because I'm just changing directory to the current directory. The other common one is double dot. Double dot represents the parent directory. So if I do this, I change my directory to WDB. Inside WDB is decal. So WDB is the parent directory for decal, right? So I can change directory to the decal subdirectory, then I can change directory to the parent directory. I can move back and forth, and I can move as far up or down in my directory that I want, right? Let's say I go one more out, I'm back at Berkeley. One more out, I'm back in documents. One more out, I'm back in my home directory, right? And so basically I'm navigating through my file structure, right? It's the equivalent of doing this. If I change my directory to documents / Berkeley / WDB / decal, do you see how I ended up in the same directory? This is laying out the file structure in kind of a single line And this is kind of going over how we can actually move through the lines. Okay, so that's how we move through. There are a few other commands like print working directory. That tells me my working directory. So my home directory, right? Let's go to my home directory. My home directory is user/Dhruvesh, right? And then as I go in through my subdirectories, do you see how my directory lines change, right? I can see exactly where I am in the file structure, right? The latest directory is a subdirectory of the left, right? So Dhruvesh is inside users, documents is inside Dhruvesh, and I can keep going down. Okay, so that's how we navigate through the file structure. Okay, are there any questions about that? I'm gonna pause for 2 seconds. CD with nothing will get us to home. Yes, that's right. That's the default argument. Okay, let me see if this works. So is Git Bash a Linux terminal? I would not use it like that. For Windows, I would recommend using PowerShell and adding all of your shortcuts to PowerShell. I'll be happy to answer questions about that offline. But I would not use Git Bash as your central Linux terminal. Okay, let's see if this works. Okay, so now we know how to navigate through our files, right? So let's start a project. I'm gonna code with you guys in real time. We're gonna make a really, really simple website. Go to Documents, Berkeley, WDV, decal, right? Here's all my decal files. Okay, Touch will make a file, okay? So Touch creates a file that we can use to do anything, okay? So I'm gonna do touch hello world.html, okay? So now I've made an HTML file. The other thing that we can do in terminal is launch commands. So let's see what happens when I do code hello world.html. It opens in, oh wait, that's kind of annoying. Hold on. Sorry. Okay, so what did I just do there? I did a lot of things, which I didn't explain. So let's go through it. First, I made a directory, make directory, okay? And I called it examples, right? So first I created a file, I touched a file called hello world.html. I made a directory called examples. I moved hello world into the directory examples, okay? Then I changed directory into examples. Then once I was inside examples, I ran a command to open the current directory in VS Code. That is a lot of things, but that is basically how our terminal workflow works. We have a series of commands that we can run, and we use file paths, and we can actually touch the internals of our computer and run programs from inside of our computer through the terminal without having to click. Okay. So are there any questions about that? Yeah, so if you're getting a command not found code, it's because you need to install or you need to add the code command to your path. So basically what happens under the hood is that when I type in a command here, it looks in path for where that command points. This is all stuff you don't really need to know, but if you want me to help you configure this code, I definitely can. Just know that it's not default behavior. It's just an example of where I can use a command to execute a program, but code is not a built-in. Code you have to add manually using like the tools. So at the core, what does code do? It launches or it executes a program, right? So every time I type a command into the terminal, I'm executing something. In this case, code executes the VS Code application and tells it to open on the current directory. Okay, does that make sense? If you guys are having trouble, it might be hard to follow along in lecture for all these like tool things, because you might not have all the tools set up that you need until you do homework 0. So you can definitely follow along in future lectures. For this lecture, if you're having trouble, I would say just hold off and come to office hours. We can debug your entire workflow and then you'll be set for the rest of the semester. Okay. So I guess I'll ask about this later, but I actually don't have Fig. Mac terminals automatically autocomplete. You don't need an extra tool for that. So if I do like code hello world and I hit tab, it will autocomplete on its own. Just a tip. Okay, so let's look at my hello world file. Okay, so I have this file. Does anyone want to make a suggestion for what we should make a web page about? Anything, literally anything. Okay, let's do pandas. Okay, that's a good idea. I like that. Hold on. This is so annoying. Okay, so I have my pandas. Okay, so you don't need to understand what I'm doing here, but basically I'm writing an HTML file. Okay, so here I have a really simple file for an HTML file, okay? And so basically what I can do now is that this file exists here, right? See how this file and this file are the same? Here, I've opened it in a text editor. What is the difference between the terminal and a text editor? The terminal helps us navigate files and execute programs. The text editor is used for writing those programs. So here I made a file, put it in a folder, and opened that folder. Here I actually wrote my file. So these are kind of the ways in which our workflow starts to get a little bit complicated, but can also be super powerful. A text editor makes it much, much easier to write code. Give me 1 second. Makes it much easier to write code in a sustainable way. So let's look at this HTML file. You might be wondering, how the hell do we do that? So I'm going to grab the file path here, okay? Then I'm going to actually go to Chrome. And Chrome has some really, really powerful dev tools. Dev tools are basically tools that we use for website development. And I don't know how many of you have ever used the like inspect element hacks or like altered a web page using an inspect element. Inspect element was specifically built to help web developers develop their websites in real time. So we can use Chrome to load web development files as if they were online, and it will render them correctly. So let's see what happens when I put this in. I get an actual HTML web page. This is real, fully workable HTML. Okay, so what happens if I change something here? Or let's see, I hate monkeys. Sure. Okay, I'm gonna save this file, right? I'm gonna check my Chrome, I'm gonna update it, and I see I hate monkeys. So literally, as my file is updating in real time, Chrome is able to render the actual HTML as I'm writing it. So this is very, very, very powerful. We will be using this the entire semester consistently. Chrome is our way of seeing what the consumer of our website will see. It allows us to fully centralize our workflow to our local machine. We don't need to upload anything in order to understand what it's going to look like. So homework 0 will walk you through how to use this, but just know that Chrome is highly recommended. I think that Edge and Firefox also have dev tools, but only Chrome will be officially supported. Yes, this is not online. Chrome is literally pulling the file from the file path that I passed it. It is literally pulling the file from my local machine and rendering it. Okay, that is the most basic development workflow. Let's go over it one more time. I made a file, right? I made a directory to hold all my files. I moved my file into my directory. I opened my directory in a text editor. Now I can actually write my files. So I made my files, now I need to write my files. I wrote my file, right? I'm using all the syntax, I'm using everything I need, right? And now that I've written my file, I'm going to actually render it. So here I've actually rendered it. I need to check what it looks like. I need to check that everything works. If everything works, then everything is dandy. And if it doesn't, then I need to iterate through and figure out what has gone wrong. That is the basic web development workflow. Are there any questions? Okay. Feel free to ask in the chat. I will, of course, be answering continuously. Or one of our TAs will get back to you. So the last part of our workflow, now that we have something and we have something that works, we need to be able to save our work, right? So I have my file, now I need to be able to save it so that I can share it, right? Software is inherently a team activity. So it would be impossible for one person to write an application the size of Google. So how do we work collaboratively and manage changes between people? The answer is Git. Git is the answer. It is a huge, 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 huge part of any modern software. That's anything from web development, firmware, MLAI, OS and compilers. Anything you can think of that has code uses Git. Git is extremely powerful for collaboration. So, what is Git actually? Okay, yeah. So to get the path, we basically can get it from VS Code using this copy path, or right, I can use this, right? I can do ls. I see my hello world.html. I can do print working directory, which tells me where I am, and then I can concatenate, right? I have decal examples / hello world.html, right? That tells me the path as well. Okay. If we want to put an image into a website, do we have to download the image on the computer? Can we just input the image link? That's a great question. Let's do a quick demo just for fun. Let's see. Oh, see? Pandas. Let's copy this link address. Okay. Let's see if that worked. Okay. I think it's getting blocked by Google. Kind of annoying. Let's see. Sorry, I'm on a tangent, but I do think this is an interesting question. There we go. The answer to your question is no. You do not need to download it. But here's the demo. Okay, so Git. Let's talk about Git. For this, I'm going to share my iPad if it will let me. It will not let me. That's kind of really annoying. Okay, let's see. What else can we do here? Or maybe we can do this. Do that. Oh my God, we can do that. Can you all still see? Hello? Okay, let's see if this will work. So, okay, I'm going to try to make this work. Okay, so what is Git? Let's see. Okay, so Git is version control, right? And what is version control? Version control is basically a fancy way of saying that we want to keep track of every single change that we are going to make. And why do we want that? Let's imagine I have a file, right? I have some text in this file, right? And I send you this file, okay? And you tell me that you hate this file and that you think the file should actually look like this. Okay, let's say you make some changes, right? And let's say I say, okay, I agree, the file kind of sucks. Let's keep those changes. Okay. Now let's say we take this file and let's say we take this file and we run it, right? And when we run it, it fails. Okay. This fails, right? I know that this works, right? But I know that this broke something. So ultimately, I want to go back, right? I want to use this file and keep changing this file until it works, right? Git is a way for us to keep track of every change we make so that we have a clear record of when and where files came from, who was working on them, and how they have changed our actual code base. So how does it actually work internally? Imagine Git is like an all-seeing creature, okay? Git sees everything. Almost everything. Okay, so I have a set of files here. I make a file, okay? Git has very, very good vision, but it only sees so much. So if I I guess maybe this is a better way to put it. So if I have Git, right? And I have there are 3 levels of Git. So this is my local machine, okay? I create a file, right? Then I need to tell Git to watch this file. In order to tell Git to watch this file, I put it on the stage, okay? The stage is basically the place where Git keeps track of all the files that I tell it to. Okay, so here's the stage. Let's say I have 3 files. These 2 are good, right? So I stage those. This one kind of sucks, so I don't want to stage this, okay? So I put these 2 files on the stage, okay? Then I commit them. Committing is where Git actually saves the contents of those files. So when I commit, Git has a history, okay? It has a history of everything I've done. Let's say time 1, time 2, I had these files, these files, these files, okay? So when I commit, it will add a new log in the history for these files, right? And so this is how it works on my local machine. So I have a Git repository which tracks the files. A repository is a folder. This can seem kind of abstract right now, but just stick with me. So I have a Git folder, and everything inside this folder that is staged will be committed to the history, okay? Let's go through an example of that maybe. So let me switch this back. Okay, and then share screen. Sorry, workflow is kind of annoying. Okay, so let's look at this. Let's go to my terminal. Okay, let's go back to our, let's say I want to save my file. Okay, so I have documents Berkeley, WDB, decal, examples, right? Okay, let's look. So I have 1 file, right? Let's create 2 more files. Let's create hello world.css, and let's create hello world.js. Okay, so now I have 3 files. Wait, can you see my screen? What can you see? Do you see my terminal? Okay, let me try again. Okay, let's try this one more time. Oh, I see why. Wrong desktop. Okay. Do you see? Oh. Okay. Do you see it now? Do you see my terminal now? Okay, excellent. So I basically created 2 files and I checked, these are my files, right? So far, Git does not exist, right? So let's tell Git to exist. I'm going to do git init. So I'm initializing git to track the files inside this folder. Okay. So now let's look. Nothing has changed, right? Git runs almost exclusively in the background. There should be no indication that Git is managing our files. Git does not edit files. It only checks the files that we're editing, right? So let's look at our Git status. Git status tells us what files are not being tracked. It tells us what files are on the stage, and it tells us what files have already been committed. So here I have 3 untracked files, right? Basically, Git is telling me that it is not looking at these files and it is not saving their state, okay? It is not indexing what they look like. Let's add them to the stage. Let's tell Git to please start tracking the files. So I'm going to git add all. This dot means all. So it will add all the files in the current directory. Remember, this dot is the current directory. So now all 3 of my files should be on the stage. Okay, let's check. Yes, so these changes to be committed, these are on the stage, right? And I can unstage them, but I'm telling Git, okay, these are the files you need to track. These are the changes that you need to track, so that when I commit these changes, this is what it's checking, okay? Now I'm going to commit. I'm going to do my initial commit, okay? When I commit, it will basically take all these files, take a snapshot of them, and save it, okay? So before I commit, let's look at my Git log. We do not have any commits, right? Now let's commit. So I'm telling Git to commit with the message initial commit, okay? Now I have 1 commit in my history. This is my first commit. It happened by me on this date with this commit message, right? Let's look at my Git status. Suddenly, there's nothing to commit. Why is that? Git does not track files so much as it tracks changes. So when I add a file to the stage, Git will track every change to that file from there. So let's make a change to the file. Let's say I change hello world to include another paragraph, right? Let's say I have P, I love red pandas, okay? Now my hello world.html has changed. Notice that this is not staged for commit, which means that this file currently, if I committed, because it's not on the stage, Git will not save these changes, okay? What happens if I make another file? Let's do goodbye world.html. Okay, what does Git tell me now? Now there's 2 types of files. There's a file which was on the stage before, but whose changes have not been added to the stage, right? These are changes not staged for commit. Then there's untracked files, which means that Git has no information and no history about them. They're brand new. So let's say I git add all. What does my Git status look like? Now I have a new file called goodbye world and modifications to my old file, hello world.html, okay? So let's commit these. This is my second commit, okay? Now let's look at my Git status. Again, I have now no changes, right? Git saved my changes and it reset my changes, or Git saved my changes and told me that there are no changes that are unsaved right now. Okay, so now let's look at my log. So here I see my initial commit, which happened earlier, and I see my second commit, which happened just now, right? So where does the real power of Git come in? The real power of Git comes in when I need to revert my changes. So let's say I have Git status or Git. So my second commit, I made this change, right? I added, I love red pandas, right? But let's say that's a lie. I actually hate red pandas. So we need to revert this change. How do we do that? Well, Git has a very, very convenient method for doing this. It's called Git reset. And when I Git reset, I can basically take the first few letters of my commit hash, okay? This is called a hash, and I can reset my files. Okay, what did that do? That, okay, let's do this. I'll explain what happened here, but let's just do this. Okay, what happened? There's nothing about red monkeys anymore. Why? I literally reset my entire directory to the saved snapshot from my initial commit. So now I only have the stuff from my initial commit. I basically restored my saved copy. What happened here is that when I pass the hard command, it basically takes all the files and literally reverts them. If I don't pass the hard, it basically takes all my files, reverts them, but then adds my changes on top of them. As in, it's as if I went back to that commit and every change since then never got committed. So do you see how it modified hello world? But here there's no modified hello world, right? Here it just literally reset it all the way back to the beginning, right? So, no, I made the CSS and JS files. So that is essentially how Git works. I make changes, I stage them. I keep making changes, I keep staging them. Once I have something that is worth saving, I commit all the changes in the stage to my saved status, as in when I commit them, that means I'm saving them, right? That is how I keep a log of everything that I've done incrementally. What happens if I do this? Nothing, sorry. I already reset it, so I can't go back there. Yeah, that basically deleted this thing, right? Because I reset it back to original state. Okay, the last part of this workflow is GitHub. GitHub is nothing more than this folder in the cloud, okay? All it does is take my Git repository, all of the version tracking, and all of the files inside, and stores it on the cloud, okay? It's basically just a way for us to mirror our work in one place so that if, say, you and I are working on the same project, I can go to your GitHub and pull down a mirror of the work that you're doing. So how does that work? Let's do this. Let's go to GitHub. Let's go to my profile. Let's make a new repository. Let's call this Git example. Okay. Okay, we're going to create this repository. All right. Then I basically have an existing repository, so I'm just going to copy these instructions. Okay. I'm going to do all this. Okay. You don't need to worry about that. Okay. And now I'm going to tell Git, whatever changes are on my local machine, please push them up to GitHub. Okay, let's see. Did that reflect on our GitHub? Yes, it did. Now you can see I have exactly the files that I had on my local without red pandas. Essentially, I'm able to manage the working state of my directory this way. And so there are a lot more richer features of Git, which we will use in the semester, and we will explain those down the line. So for now, this is enough to get you started. And if there's anything more, we will explain it at a later time. Okay, that's kind of it. Are there any questions? So let's review it quickly. I'm just going to, yeah, I'll need to update the slides and send them out, but I will send out the slides with all the Git commands, and they're also listed in the homework 0. So you can definitely check there. But yeah, so git reset commit ID hard will turn you back to the first commit. It will turn you to the commit ID which you put in. So I could have also reset to commit 2, which wouldn't have done anything. Did you have to make a repository on the GitHub website before you can make the remote into it? Yes, you need to initialize the repository on GitHub, and then it will give you instructions for how to like basically use that repository as a mirror of your local. Okay, are there any other questions? Okay, in that case, that does conclude this lecture. There will be announcements coming out about the social this Friday, which I highly encourage you to come. And there will also be announcements about submitting homework 0 via Gradescope. As always, if you have any questions, please feel free to reach out. And we'll gladly. Is the homework 0 due tonight? Absolutely not. It's due 1 week from today. Yeah, the due dates are on the website. Okay, I'm gonna stick around for 2 minutes, and then if you have any questions, let me know. If not, have a great day. There is Zoom. The B courses will not be used for this decal. Magic word, there is no magic word for this decal for this semester's iteration. Can we do git reset to previous version and stage a commit after editing it? I remember git reset allows only changing files, but doesn't allow us to go back and make edits. What you can do is you can basically go back to a previous commit and create a branch. So you can branch from the commit. You can branch from the commit and make changes on the branch and then try and merge the branch into main.